Hello everyone, my name is Prashant and I welcome you all in yet another class of HCF and LCM. This is on YouTube channel. The name of the channel is Competition Valley, and we have done few other videos as well. I believe that some 20 videos, so you can go through them as well. Those will be very important for you if you are applying for CAT or maybe CSAT or any other management or aptitude based examination like GMAT or even for SSC-CGL. It will be very useful and handy. So in our last videos, we have studied one class on HCF and the other was on LCM. Today we are going to establish some relations between HCF and LCM, and we'll see how is it useful. Okay, so let's start. The first thing is that LCM would always be greater than HCF, although it sounds highest and lowest, but see, this is a factor and this is a multiple. Okay, lowest common multiple and highest common factor. So that's why the name only suggests, so don't go with lowest and highest. HCF is always smaller than the LCM. This is very important properties. Okay, you would have many questions, not in CAT, but in many other examination, you would have questions wherein you will be trapped in such things. Second thing would be LCM would always be equal to something HCF, always. Okay. So these are the two very important properties, and we'll check. Let's say LCM we check for 4 and 6. Okay, and we will do HCF as well for 4 and 6. Okay, simple. So for 4 and 6, the HCF would be any number. It should be 2, I believe, and this should be, I believe, 12. Okay, so first of all, you see LCM is what? LCM is greater than the HCF. This is fulfilled. And LCM is what? LCM is something. LCM is something into HCF. So K is equal to what? LCM by 2, which is 6. So both these concepts or relations have been satisfied. So there would be so many questions based on this. So we'll do a couple of them now. Now the question, the product of two numbers is 120. If their HCF is 40, find the LCM. Okay. Simply, as we know that in our last slide, we studied that LCM would always be something of HCF, isn't it? So what it means is LCM into product of two numbers would be LCM into HCF. This is always true. Okay, this is always true. Okay, I believe I didn't do this in the last slide, but this is always true. For example, when we took LCM of 4 into 6, it was I believe 12, and HCF was of 4 and 6 was 2. So if you multiply 4 and 6, it will be equal to 12 into 2. So N1 N2 is equal to LCM into HCF. This was the third one we missed out. Okay, so this is third such relations. Now we know this N1 into N2 is equal to LCM into HCF. We have learned just now. So what we can do is, it says the product of two number is 120. Okay, LCM we need to find. HCF is 40. So very simply LCM would be what? 120 by 40 equal to 3. We can be tempted to give answer as 3, but it would not be true. Why? Because see, LCM is always greater than equal to HCF. LCM, what it is coming? 3. HCF is what? 40. So this rule does not satisfy this equation. Therefore answer will be what? Inconsistent data or none of the above. Whatever the options would be there, you need to find that accordingly. Okay, we'll do another question. Now the question says the product of two number is 120. If LCM is 20, find the HCF. Okay, now we know that N1 N2 is equal to what? LCM into HCF. The multiple of it can be done. So it says the product of two number is 120. LCM is what? 20. HCF is what? We need to find. HCF would be 120 upon 20 would be 6. Now this is LCM is, see, greater than HCF. So it should be satisfying this. Since it is satisfying, it should be the answer, but no. This would not be answer. Again, why? Because we know that LCM is what? K into HCF. We studied this. Or we can say LCM by HCF is equal to K. That's what we should have. So over here, LCM is what? LCM is given as 20, HCF is given as 3. So it does not satisfy this equation. Okay, so it's not satisfying this equation. Therefore, again, it would be data inconsistent, or it could be none of the above, or anything. Whatever is the option, look for that. But don't fall trap into such things. Okay, if it is given, just think for a moment what is happening. It should always satisfy these two equation. One is this, and the second is LCM is always K into HCF. Always these two equations it should always satisfy. Okay, we'll do another question now. So this is a question. LCM of 12 to the power 10, 64 to the power n. LCM of 12 to the power 10, 64 to the power 9, and n is 24 to the power 18. How many values can n take? So what we have studied in our last video, that LCM always takes the highest of power of prime base. So can we write these in form of prime base? So 12 is what? 2 to the power square into 3 into 10. So what it would be? 2 to the power 20 into 3 to the power 10. Simply 2 to the power 12. So this is how we have done, 20 and 3 to the power 10. 64 can be written as 2 to the power 6 into 9. So can it be 2 to the power 54? And then we have n. And on the other hand, we have 24 into 18. So 24 into 18 what? It's 8 into 2 cube into 3. 8 into 3, 24 into 18. So can we write 2 to the power 54 into 3 to the power 18? Can we write it not? Now see, what are the numbers that we have now? Just look for it. We have 2, then we have 3 over here, and then we have 3 over here. Okay, so if I have to write it, this equation n, so what would be the highest power of 2? The highest power of 2 would be 54. Okay, now in this equation, okay, any number between 2 to the power 0, 2 to the power 1, 2 to the power square, 2 to the power cube, till it goes to 2 to the power 54, it's not going to make any changes, because the output of this, as we studied in our last video as well, that up to 2 to the power 54, this LCM would not change, because the LCM has already taken the value of 2 to the power 54. So even if 2 to the power 53, 52, 51 does not change. So 2 can take value up to 2 to the power into 2 to the power 54. Now n is fixed. See, 3 to the power 18, because over here if you see, we have 3 to the power 10. You don't have n in our second number. And I'm sorry, we are talking about 3. So we have 3 is 3 to the power 10 over here. And in a second number, we don't have any power of 3. So the n can be, the max is 3 to the power 18, because that's a maximum value. So n is fixed at 3 to the power 18. So how many values can n take? N not, I'm sorry. This 3 is fixed. Okay, 3 is fixed at 3 to the power 18. And 2 is up to 2 would range from, n would range from 2 to the power 0 to 2 to the power 54, making a total of 55. So n can take 55 values. What it means is, any number at n can take between 2 to the power 0 to 2 to the power 54. This equation would not change. The LCM would remain the same. That's why n can take 55 value. We'll do another question. Okay, we'll do a couple of more questions such, so that you understand the concept. It's based on highest power. We studied this in the last video as well, that LCM takes the highest power of prime bases. So we have broken into the prime bases, and then we have seen what like 2, what's the highest, 3, what's the highest, what we are getting, and accordingly we can do that. Okay, we'll do another question. So this is a question. It says LCM of two natural numbers P and Q, where P is greater than Q. Very important. Always, any variable, any condition that is given, always focus on that. Is 935. What is the maximum possible sum of the digits of Q? So let's say Q is a 2-digit number or 3-digit number. It could be anything. So we'll have to find what is the maximum possible sum of all the outcomes. Now it says LCM of two numbers. So we have studied in co-prime method. That if LCM is what? H into A, H into B. So what would be LCM? LCM would be H into A, B. Okay, so let's take P is A and Q is B. So we have H into AB is equal to 935. Now 935 can be written as 5 into 11 into 17, isn't it? So now we can start. This is would be entirely a hit and trial method. So we can take, let's say, if we take H is equal to 5. Okay, so if you're taking H into 5, so this is what we are doing, 5 into something. So we have to take A has to be bigger, because we are denoting A as P, so A is bigger number. So it will be 17 and it will be 11. Then our HCF would be 5 into 7 into 11. I'm sorry, 5 into 17 into 11. So this is 85, this is 55. So the sum is 10. We just have to take sum of Q. So this is 10. Now in case 2, we can go for case 2. In case 2, we can take H equal to, we can take, let's say, 11. Then what happens? We have to again take 17 and 5. That's what we need to do. So 11 into 17 into 5. Again, we are getting 55. So again, it's 5 plus 5 equal to 10. Now we have to take case 3. In case 3, we can take H equal to 17. If I take 17, then it would be again, if I take H equal to, H we have taken 5, H we have taken 11. Now H we are taking 17. So if we are taking 17, it would be 11, it would be 5. So the LCM is 17 into 11 into 5. So again, it's 85. So it is 13. So as of now, we have got 13, looks to be highest, but we can still, we have to look for more options. So we are looking for case 4, wherein we can take H, we can take as, let's say, 11 into 5. We can take 55 as H. So in that case, what would happen? If I take this thing, so 55. So one of these would be 55 into 17, and then this situation 55, like it's 11 into 5 basically I have taken. So it's 11 into 5 into 7 into 7. So this would be 1 in that case again. So it's not going to help us anyhow. Again, it will be 10. So case 5, we can take case 5 as, next we can take H as, this is where we have taken 5 into 11. Now we can take H is 5 into 17. So it would be what? 11. Again, it into 1. So it will be 85. So again, it's 8 plus 5 is 13. So now what do we have left? We have one more case left, wherein what we can take? We can take, we have taken H5 into 11. We have take H5 into 17. So we can take, yes, we can take 17 into 5 now, I believe. 17 into 5 or 70 we've taken. It's already taken. So what we can take now is H we can take into 11 into 17. Okay, over here we have taken H only as 11. So don't get confused. Okay, so if I do so, 11 into 17. So what we get? We get 5 over here and we get 1 over here. So what do we have? 11 into 17 is 17 and plus 1 18. So you have 8 1 9 16. So that's our answer. See what we have done now. It's very simple. The question looks very difficult, but it's not at all. We have just broken 935 and into prime factors, and then we have to we have studied this in our co-prime method while we calculate LCM. If you have not studied, please go back and refer there, otherwise you may not be able to understand it. That H into A and H into B, if we want to say A and B are co-prime, so LCM would be H into A into B. This is LCM. If this had to be HCF, it would have been only H, but this is LCM. So LCM is what? It's always something into HCF. So that's what we have done over here, 935. Now we have started taking H different possibilities. So we can take H as first 5, then 11 and 17, and then we can take in 2 digits. We can take H as 11 into 5, 11 into 7, 5 into 17, and that's how we need to find. But we have always to remember that P is greater than Q. This makes our question very, very easy. When P is greater than Q, you just need not to focus on P, you just have to focus on Q. So get the sum of Q and add it up, and you will find this answer. If you have not understood it, drop it in the comment box and I'll again explain it to you. Just look for a moment what has happened.